Hi students, in this video, we will be discussing the derivation of Lensmaker formula. The video is divided into two parts. First, I will be deriving the spherical refraction derivation, and then after that, we will be deriving the Lensmaker formula as a result of spherical refraction. Watch this video till the end to get the complete derivation. If you have not yet subscribed to Easy Exam Academy channel, please do subscribe and click that bell icon for more updates. Let's get started. As a first part, we will be seeing the derivation of the spherical refraction. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. That is the standard formula that is given in the textbook. But I always ask my students to remember in this way. Mu output divided by V minus mu input divided by U is equal to mu output minus mu input divided by R. So because the output medium and input medium should be clear for you, whatever the refractive indexes that they are giving, you need to use the output and input medium reference and do it. You will not get any confusion. This is the diagram that you need to be drawing in the examination. You need to draw the diagram in a neat and legible manner by using scale and pencil and mark all the values as shown. Now here the m dash will coincide with m because this is assumed as a thin spherical surface. So I can write n m dash is equal to n m. Consider the triangle n m dash o. Here tan alpha is equal to n m dash upon o m dash, which is equal to n m upon OM. For the small angles, I can approximate tan alpha is approximately equal to sin alpha is approximately equal to alpha because of the small angle approximations. Similarly, I can consider triangle n m dash c where tan beta is equal to n m dash divided by m dash c, which is equal to n m by mc, which can be written as beta. Similarly, consider the triangle n m dash I. We can tell tan gamma is equal to n m dash divided by m dash I, which can be written as nm divided by mi, which is equal to gamma. So this is the first step in the process. I can summarize this as alpha is equal to nm by om, beta is equal to nm by mc, angle gamma equal to nm divided by mim. Now consider the triangles I, alpha and beta, that is n, c and o. Similarly, consider the other triangle. This is angle beta, this one, that is n, c and I, gamma, and this is r. By using the exterior angle sum property of the triangle, I can write alpha plus beta is equal to I, and similarly I can write here beta is equal to r plus gamma. So from here I can write r is equal to beta minus gamma. By using the result obtained in the previous page, we can write I is equal to nm upon om plus nm upon cm. Similarly, r is equal to nm upon cm minus nm upon im. Now applying the refractive index formula, that is the Snell's law, sin I by sin r is equal to mu output medium divided by mu input medium, which is equal to output is mu2 where the ray is leaving and the ray entering is mu1. So from here I can write for small angles I can approximately write sin I is approximately equal to I, sin r is approximately equal to r. Now cross multiplying I can write mu1 into sin I is equal to mu2 into sin r, which comes out to be mu1 into I is equal to mu2 into R. This is the equation. Now having the equation mu1 into I is equal to mu2 into R and substituting the values of I and R that are been previously derived, mu1 into nm upon om plus nm upon cm is equal to mu2 into nm upon cm minus nm upon im. So you cancel all the nm's out. You will get mu1 upon om plus mu1 upon cm, which is equal to mu2 upon cm minus mu2 upon im. Now rearrange it. Mu1 upon om plus mu2 upon im is equal to mu2 upon Cm minus mu1 upon Cm. Now taking instead of Om, I can take it as minus U by using the Cartesian sign conventions and substituting the values. Mu1 upon minus U plus mu2 upon V, Im is equal to V, and this will be mu2 minus mu1 upon R. So rearranging this, we can get the equation mu2 upon V minus mu1 upon U is equal to mu2 minus mu1 upon R, which is the spherical refraction formula. I will be writing this as mu output divided by V minus mu input divided by U, which is equal to mu output minus mu input divided by R, which is the easy way to remember without any confusion. Now let's proceed to derive the Lensmaker formula. Lensmaker formula is given as 1 by F is equal to mu2 minus mu1 by mu1 into 1 by R1 minus 1 by R2. 1 by F is equal to mu output minus mu input divided by mu input into 1 minus R1 by 1 minus R2. This is the way that I tell my students to remember to avoid any confusions with the refractive indices. The image that is formed by the lens can be represented in these two ways. Initially, let us consider a biconvex lens which is very symmetrical and the object is placed here and the image is found here. This undergoes two spherical refractions and I have separated it into two things like this. So this is the first interface refraction. The object O is forming a image I dash here. And the second one goes like this. This image acts as an object for the second surface and that is forming the final image at I. You clearly observe that this input medium is mu1 and this input medium is mu2 and there is a change that is required in the mu2 minus mu1 and mu1 minus mu2. So for the first one I can write by using the spherical refraction equation mu2 upon V dash minus mu1 upon U is equal to mu2 minus mu1 upon R1. And for the second equation I can write mu output medium is 1, so final image, minus mu2 by V dash. This lens is a symmetrical biconvex lens. That is why the distance from this surface to the image is same as the distance from the second surface to the image. So we get the same distance as V dash and V dash. So that is why we write like this. It is equal to mu1 minus mu2 divided upon R2. Now adding both the equations, this both get cancelled. I can write mu1 upon V minus mu1 upon U is equal to mu2 minus mu1 into 1 by R1 minus 1 by R2. I can write 1 by V minus 1 by U is equal to mu2 minus mu1 divided by mu1 into 1 by R1 minus 1 by R2. So this is the Lensmaker formula. We have come to the end of the video. If you have any doubts, please feel free to post in the comment section. And if you want more videos like this, comment what topic you want. I will be posting the video regarding the same. Thank you.